Good afternoon, friends. Today we will discuss motional EMF or relation between induced charge and changing flux. Now, what do you mean by motional EMF? Motional EMF means the EMF induced across the ends of conductor due to its motion in a magnetic field is called motional EMF. Now question is, sir, what are the factors producing the EMF? This is a very simple question. There are three factors to produce the induced EMF. First, due to change in magnetic field, or you can say due to change in magnetic flux. Second, due to change in area placed in a magnetic field. Second, relative orientation of point with respect to field. So motional EMF means the EMF induced due to its ends of conductor, due to its motion of a conductor in a magnetic field is called motional EMF. Suppose this is a conductor, PQ is a conductor, PQ is a conductor placed in a uniform magnetic field B. Placed in a uniform magnetic field B. Having length N, PQ equal to N. This conductor is placed in a U-shaped ray situated in a uniform magnetic field B. This conductor moves inwards with velocity v. This conductor moves inward, velocity v, area change. This conductor moves outward, area increase. That means area increase or decrease. So due to area increase and decrease, induced EMF set up. So conductor PQ moves inward with velocity v. So flux is changed, phi is equal to B. Now, phi is equal to B. A means area means length into breadth. Suppose this conductor moves inward, suppose this distance is x, or you can say breadth is x. So phi is equal to B at this is area. But we have calculated induced EMF. So according to Faraday law, E is equal to minus d phi by dt. This is Faraday law. So induced EMF E equal to d by dt B L x. B L and dx by dt. So induced EMF is equal to BL because dx by dt is velocity. So this is the induced EMF. E is equal to minus BLV. Minus sign indicate direction. Direction is given by Fleming left hand rule and Lenz law. Now question is, what is Fleming left hand rule? Fleming left hand rule, we stress a Fleming left hand and in such a way thumbs, forefinger, center finger are stressed perpendicular to each other. This indicate, this is a center finger, this indicate direction of current, this indicate magnetic field and this indicate motion. This is the Fleming left hand. So motional EMF E is equal to d phi by E is equal to minus BLV. Suppose we have to calculate induced current, I is equal to E by R. E means BLV upon R. This is induced current. Suppose we have calculate force, F is equal to Will. Putting the value of I. I means B L V on R I means B L V upon R into. So that is B square L square V by R. This is force. Now third one we have to calculate power in P is equal to I square R. Putting the value of I means B square L square V square upon R square into R. So that is B square L square V square upon R. So there are three cases. This is induced current, this is force, and this is power. Now a very simple question. A magnetic rod of length L is rotated in a uniform magnetic field with angular velocity omega, placed in a uniform magnetic field. Uniform magnetic field B. This is a rod of length L moving with velocity omega, angular velocity omega. Derive an expression. First induced EMF, second induced current, third one is force or power as you like. Consider a rod of length L placed in a uniform magnetic field, rotate with angular velocity omega. So flux is changed. Phi is equal to BA. BA means area. So what is flux change? D phi over dt by t upon time. So phi is equal to E is equal to d phi by dt according to Faraday law. So phi means pi L square upon t. T that is B pi L square frequency. 2 pi frequency equal to omega. Omega is equal to 2 pi nu or F. So what is F? F is equal to omega upon 2 pi. Putting the value of F. So induced EMF B pi L square omega upon pi cancel pi. So that is half B L square omega. This is induced EMF. Now we have to calculate, suppose induced current I E by R. Value of E half B L square omega by R. Suppose we have to calculate force or power, F is equal to B. Putting the value of I. So we have calculated three derivation: induced EMF, induced current, force. Okay. So this is the motional EMF. Or now one topic is change in flux or induced charge. There is some relation. We know that according to Faraday law, E is equal to minus d phi by dt. But I is equal to E by R. What is the value of I? dq by dt. What is the value of E? Minus d phi by dt into R. So dq equal to minus d phi by R. This is the relation between induced charge and change in flux. That means induced charge does not depend rate of change of magnetic flux. Okay, thank you.